All right, we're going to go on an incredible journey to the center of the Earth, but, without ever leaving our seats. It's really a fascinating detective story about how scientists cracked the case of what's hiding thousands of kilometers right under our feet.
It's a wild paradox when you think about it, isn't it? I mean, we have telescopes that can see galaxies billions of light years away. Yet, the inside of our very own planet has been one of the biggest mysteries out there. So how did we figure it out? How do we possibly know what the core is made of when we can't see it, we can't touch it? That's the big question we're digging into today.
So before we get into the how we know, let's talk for a second about the why. Why is it so important to understand what's going on deep inside our planet anyway?
Well, it's because everything is connected. The incredible forces that can trigger a massive earthquake or build a volcano, the processes that form the valuable minerals and resources we rely on, it all starts with the immense heat and pressure deep inside the Earth. So you see, this isn't just for curiosity's sake. It's about understanding and maybe even predicting natural disasters, finding resources, and really just grasping the fundamentals of how our world works.
Okay, so if you want to know what's down there, the most obvious approach is, well, to dig, right? Just go down and see. But as you're about to find out, that's way, way harder than it sounds. In our geological detective story, let's call these our first set of clues, direct sources. This is basically anything we can physically get our hands on and analyze. A chunk of rock, a bit of magma. This is our tangible, real-world evidence.
And we've got two main ways of getting this evidence. The first is, of course, drilling and mining. You've got gold mines in South Africa that go down almost 4 kilometers. The second is we can just wait for the planet to send us a sample during a volcanic eruption. That lava is like a messenger from the mantle. But both of these methods have one huge problem.
This is it. This is our record, 12 kilometers. It was a massive Soviet drilling project that really pushed engineering to its limits, an incredible achievement. But the craziest part wasn't what they found, it was what stopped them. And it wasn't super hard rock, it was heat. The temperature down there hit 180 degrees Celsius, way hotter than they expected, and their drill bits just started to melt. So remember that number, 12 kilometers.
Because this is the distance to the center of the Earth, over 6,000 kilometers. So that record-breaking 12-kilometer hole, it doesn't even make it 0.2% of the way to the center. That's like barely scratching the paint on a car. It's nothing.
So the bottom line is, digging is a total non-starter. The heat and pressure down there are just so unbelievably immense that our best equipment would be crushed and melted in an instant. Our direct investigation has officially hit a dead end. We need a new lead, a totally different way to see what's down there.
And that new lead, our big breakthrough clue, actually comes from one of the most powerful and destructive forces on Earth, an earthquake. At its heart, an earthquake is just a gigantic release of energy. Think of it like a massive flashbulb going off deep inside the Earth, sending out waves of energy in every single direction.
The energy release starts deep underground at a spot called the focus, and the point on the surface directly above it, where all the shaking happens, is called the Epicentre. But for our detective story, the key isn't what happens on the surface, it's the energy that travels through the planet itself. And these are called seismic waves. They're basically sound waves, little echoes that ripple through the entire planet after an earthquake. And just like a doctor uses an ultrasound to see inside a patient, geologists can use these seismic waves to get a picture of what's inside our world.
Okay, this is where the detective work gets really, really clever. So we've got these echoes bouncing around inside the Earth. How in the world do you translate those faint rumbles into a detailed map of the planet's interior? Well, first, you got to know that these waves come in two main flavors. There are body waves, which, as the name suggests, travel through the body of the Earth, and then there are surface waves, which only travel along the surface.
Here's a really simple way to think about them. The surface waves? They're the destroyers. They're the ones that cause all the damage, making buildings collapse. They're powerful for sure, but they stay on the surface, so they don't tell us much about what's deep down. But the body waves? Now those are the messengers. They travel right through the heart of the planet, and they carry its secrets with them.
So, let's follow these messengers, because the information they carry changes based on the material they travel through, and that little detail is the key to everything.
Now, these body waves themselves are split into two types, P waves and S waves. P waves are faster, and they can travel through pretty much anything, solids, liquids, you name it. But S waves can only travel through solids. If they hit a liquid, They are completely stopped, dead in their tracks. This right here, this is the scientific smoking gun. This single distinction would completely change our understanding of the Earth.
I mean, really let that sink in for a second. This one simple property, that S-waves just can't pass through liquid, is what allows us to map a world we can never visit. It is the master key that unlocks the entire mystery of the Earth's interior.
So, we have our clue. We know the secret of the S-waves. Now let's see how scientists put all the pieces together to create a picture of something that no human has ever or will ever see.
It's really a brilliant piece of deduction. So an earthquake happens, sending P and S waves out in all directions. All around the world, seismographs are listening, recording when those waves arrive. And scientists started noticing something weird. On the exact opposite side of the planet from an earthquake, there were these huge areas, they called them shadow zones, where the S waves just never showed up. They vanished. The only possible explanation? They must have hit a massive liquid barrier deep inside the planet that they couldn't get through. And that barrier, we now know, is the Earth's liquid outer core.
And that's the result. By analyzing how P waves bend and change speed, and paying close attention to where those S waves completely disappear, we can actually map out the solid crust, the gooey mantle, the liquid outer core, and even the solid inner core right at the center. We are literally seeing with sound.
So, we solved the mystery. How do we know what's inside the Earth? We listen. We listen to the echoes from its own powerful, churning heart. It really makes you wonder, doesn't it? If we just keep listening to the faint rumbles and whispers of our own planet, what other secrets is it waiting to tell us?